Was gibt's denn zum Essen gerade? What do they deliver? What food is out there? What? Schnitzel? Nah. I see people running around with food. What food is out there right now? Butterkeks. Ja, super. Leibniz hoffentlich. Nur echt mit 32 Zähnen. Hast du das eben? Ja, da beißt du schon. Sehr gut. All right, folks, we are getting ready for the last breakout of the day of the event. Fun fact, because we just talked about Butterkekse and so sweets. Who in here likes Gummibärchen? Awesome, you get at least 1, 2, 3, 4. Because one of the things that you told me is that you're giving away Gummibärchen in exchange for GitHub stars.
Yes.
Yes. So he has like these little packages of Gummibärchen, and if you want Gummibärchen, Philip is the man.
Yes.
All right, a couple of other things on the next session is what we hear a lot about Kubernetes operators, how to develop them using Java. Actually, Thomas, who was speaking here earlier, he gave you a little plug that and a good session to attend. You have a live demo planned. What else is there that we should need to know about you?
A little bit of history, like story time, how we integrated into the cloud provider, what obstacles did we have to overtake, what challenges we faced, and how it was possible.
Sounds good. Yeah. There's even more people coming in. They don't run away. It
Perfect.
sounds that's exactly what they want to hear. With this, a big round of applause, and then you take it away.
Yeah, thank you, Andy, for the introduction and organizing such a great event. Really happy to speak here. And awesome to have the first KCD in Vienna, hopefully many more to come. I'm from Glassstrip, I'm one of the co-founders. This is our main logo, our Kubernetes Operator. And today I bring you along a story on how we integrate it into a cloud service provider. About me, my name is Philip. I'm one of the co-founders. I studied at the Vienna University of Technology. Was CTO for a company doing alerting for firefighting organizations and also enterprises, Blaulicht, SMS, and SafeRage. And if I'm not coding, I'm actually super sporty doing floorball, one of the niche sports not a lot of people know, a little bit of triathlon, and on my holidays, I'd love to surf. Happy to connect to everyone. These are my profiles on LinkedIn and Twitter. Not sure if Twitter or X, but nobody knows. But it's just me standing here, but in reality, it's always a team effort. And also, I want to express my best thank you to the whole team, making everything possible. Also, Laura is here from our team to help with photographs. So, what does Glassstrip do? We heard a lot about IDPs, internal developer platforms, and I faced a challenge of operating open source tools for multiple years. It's hard to update them, right? GitLab makes one update every month or every 2 weeks, basically, and some security updates in between. Yeah, there are tools like Renovate we heard about that help you automate it, but in the end, it's still a manual task. And we wanted to build an application delivery platform for exactly these open source tools. And we thought on how can we do it and how can we give access to this open source tool to the broadest or to the most people possible. So we also thought about, hey, it would be super nice to implement into a cloud service provider that users like you who have access to the cloud service provider and don't want to care about anything, but still want to be in control over the data and say in which region or data center the data should be stored, have an easy interface and can deploy these tools with a click of a button. And this is actually not the real thing. This is a mock-up, which we draw, I think, 6 months ago. And 3 months ago, we actually went live with the integration to Exascale, and I now want to bring you on the journey of how it was possible. So the question is, does the thingy work? Yes. So how it was possible, I think 4 main points helped us to integrate that fast. First, we'll talk a little bit about the Open Service Broker API, what is it and how does it work. Second, obviously it's Kubernetes. We are here for the KCD. And then we go a brief introduction about the Glasscube Kubernetes Operator, how it does it, how it works in Java actually, why we did it. And then we just browse about dev toolings we use and give a little demo on how it works. So, Open Service Broker API, what is this? Does anybody know what the Open Service Broker API is? Does anybody heard about it? Okay, perfect. It was actually founded by Cloud Foundry, which is an organization with affiliation to VMware, I think back in 2019 in a Kubernetes conference back in Toronto, and they had a plan, Cloud Foundry, to abstract cloud resources and create one standardized API in delivering cloud resources to customers. So and it was actually adopted by all the major cloud service providers like Azure, AWS, and GCP. And it had its peak back in, I think, 2020, 2021, but I think then all the cloud providers recognized, okay, if there's a standardized interface that anyone can like provision resources, there's no vendor login, and so they like adopted it. It was like integrated into Cloud Foundry and is now mainly used by SAP. But why is it relevant for the marketplace integration? But I think how the Open Service Broker API works is a perfect tool of providing services to multiple cloud service provider. In the case, we can act as Open Service Broker and providing a REST API, and as it was, like Exascale already implemented the Cloud Service Broker API, so there was like a standardized interface, so we can deliver this open source, managed open source applications to customer via the cloud service provider marketplace with the Open Service Broker API. And it's basically just REST. So everyone interested in implementing into their marketplace or interacting with our platform, it's just one REST request, and then the Open Service Broker API responds with services, plans, and bindings. Services give you a list of what services are there. Plans are like the price plans on how much you get charged, and what's the description of the price plan. And then we have bindings, which will give you like access credentials to these services. And in the theory, it's a super nice and simple concept, and this helped us a lot in integrating into the cloud service provider. Next question is why Kubernetes? And I think I don't need to answer this question here in the room, obviously, but I like to say that we heard about it. It's like a steep learning curve. It brings a lot of abstraction from the ground up, but I think it's an awesome interface on abstracting resources of cloud service provider. Kubernetes guys, they thought about a lot of stuff, and it's there for you to grow. Yeah, you can start simple, deploying just some deployments, I don't know, releasing some Helm charts, and then you can grow and grow, and then you get sometimes into error budgets. Yeah, how much budget does my application have to go down? How many pods can go down, and service level won't get affected? So like autoscalers can work. Yeah, network policies on how to route traffic internally, and it also works well with other tools like Exascale, and most all cloud service provider have like Terraform provider to provision resources as infrastructure as code, and obviously Flux, Argo CD are the best tools of bringing your infrastructure as code into your cluster. This brings me about the tooling. What tooling do we use internally? Hopefully there are some tools there that you don't know yet. We are a big fan of Git. I think it's the small version of GitLab. They now released their own CI/CD, but we still use like Woodpecker. It's like having your own runners in your own CI makes everything fun. We really like use open source tools all the way. So we communicate over MetaMost, using like Git, and now for project management we actually use Plain, so it happened. All these tools are also supported by our operator. So let's continue with the controller flow. So just to recap for everyone who is not like that deep into operators, a controller in Kubernetes only has one job. Its job is to reach the desired states and bring the actual state, which is defined in the manifests, to the desired state. And it does this by constantly the constant reconciliation loop. So it reconciles all the desired state files, looks up the actual state, and then adjusts as desired. And the operator pattern extends this reconciliation loop. So you can create your own custom resource definitions, and then your own custom resources based on this custom resource definition. And you say, okay, for these custom resources, I'm the operator. You can, if some resource gets created, you can ask me. I'm the Kubernetes control operator in this case for this custom resource, and it's my job to bring the cluster into the current state. And if everything changes, like a node goes down or a new resource gets created, any other notable change, the Kubernetes reconciliation loop calls me as an operator, and I can adjust. And also I can do my own loops. Yeah? I can look up, for example, at the ingress controller and see, okay, how many requests are my current instances getting? Maybe do I need to scale up my service? Do I need to go scale down the service? And this operator pattern for us was the logical step further, because I think everyone in the room started with deploying Helm charts, but this is something you do from the outside in. Yeah, you have your command line and you deploy your manifest into your cluster, but you have no chance. Helm has no chance in dynamically interacting with the cluster. So if you delete a deployment that was deployed via Helm chart, nobody notices it, and it will just not be there anymore. But with a Kubernetes operator, actually the operator will check it all the time and can dynamically adapt the deployment and bring the deployment back up if it got like accidentally deleted. And so Kubernetes Operator is for us the next logical step for deploying applications, and we couldn't have done it with Helm charts. So this is our Glass Script Kubernetes Operator. As Andy already said, I'm exchanging suites for Gummibärli for GitHub stars. It's one of the most important metrics, and I want to highlight 3 points. I start with the bottom. It's actually written in Kotlin. Yeah, you may ask, yeah, Kubernetes, why isn't it written in Go like everything? And it's just a team. We have year-long experience with writing code in Kotlin, and for us it was a logical choice of building one monolithic operator as fast as possible, because in the end we're just defining a custom resource and then delivering the result. And we can easily swap it out to smaller, more precise operators written in different languages later on. Second thing is contributors. As Thomas already mentioned, thanks to all the contributors, we are happy to accept pull requests, bringing new features live, and also improving the operator. Special thanks also to Martin. I promised it on LinkedIn 5 minutes ago to highlight the MariaDB operator, which is an operator we use internally to provision MariaDB instances. And yeah, big shout out to him. He's also doing a great job and also helping our project. And then obviously stars. I think we're at 70. My goal is today to reach 100 stars. There should be enough suites for everyone. So yeah, hopefully we can do it. So next step, the Java Operator SDK. I think you all know the Operator SDK in Go, which like helps you. It's a boilerplate operator, helps you scaffolding your own operator. But the Java Operator SDK is actually also mostly sponsored by Red Hat and part of the operator framework repository, I think, since 2 weeks ago. And it's also getting strong momentum, and it helps you to bring your Java application into custom resources. So how does it look? You can just create your Java model. In this example, we create a spec for web servers. You can set the attribute, it's a string, it's an HTML. And you can also set like the metadata annotations with group and version. And actually it's the Fabric 8 Kubernetes client submodule, but it's integrated in there. Will from this model then create the custom resource. So this is the first spec, defining the custom resource definition. Second, as every Java application, it needs a public static void main method where you initiate the operator, and then you can register your reconcilers, right? Reconcilers are the things that are called via the reconciliation loop. Then you need to start it. There are actually also starter templates for Spring Boot. So if your organization is already heavily invested in Java Spring Boot, you can, with your existing team, start and create Kubernetes operator without getting all the knowledge from Go experts and not learning a new language. So this is the main focus, and there are like, I think, starter templates for Quarkus, Spring Boot, or you can just make it with vanilla Java, and as we do with Kotlin. Second thing is the controller, right? If you talk about the REST API, you would have a controller. In this case, it's still REST, but it's a reconciler, which then gets called on every reconciliation loop, and you just can put your custom logic in Java. So for example, it will give me as a body my spec of the resource created, and then the operator can create resources in the cluster, or just call external services. For example, if you would instance a new service via operator, we will call automatically storage APIs like MinIO to automatically create a bucket, automatically set up Postgres backups, and everything else. So there are a lot of client APIs for the Java language, which can be easily integrated. So enough talking. I think we are good in time. Now we can skip over to the live demo. I will mirror the screen so don't I get a broken neck. Let's see if everything works. So actually, okay, perfect. Exceptions, we all love this. And I think today we take a look at Git, and we saw it in the code sample before. I need to port forward my MinIO service so can interact with the database. Perfect, looks better. We talked about the reconciler before, and it was just a Hello World example. In the real world, with annotations, like Java, you have annotations. You can also define dependent resources. So in the moment my Git reconciler gets called, it has the dependent resources like a Postgres backup, a Postgres cluster, MinIO secret, and all the volumes. So you can, for example, say depends on, and the Git deployment will only be created inside your cluster if the Postgres cluster was successfully created. So you can also look at the state of the Postgres cluster, or if your volume got provisioned, if the secrets are automatically generated. And these are done with the dependent resources. There are some event sources. If you have multiple resources from the same type, you need to differentiate them with the event sources. And you can also make your own ready conditions. So when is a Postgres cluster ready, right? Is it there when it was initiated, or how? So you can make with ready conditions. You can say, is the ready condition? Yes, with your ready condition, you can say with the status that if the status is good, then it's ready, and then the dependent resource will go on. So I actually switched from ZSH to Fish and Starship last week, and it's a crazy performance difference. I just wanted to show you. If I create a new ZSH shell, it takes, I don't know, 2 seconds, and if I create a new Fish shell, it's instant. So if you still use ZSH, it's finally time to migrate to Fish and Starship. So, but it's a Fish shell, so it's not compatible with ZSH scripts. So some of my shortcuts don't work yet. So we can look at the Git, right? I hope we can. No, we're not there. This looks no. Operator demo. Yeah. Operator demo. Operator demo. Yes, perfect. So we have a custom resource from our API version. It's a kind Git name spec namespace. We just need to define the host. So Ingress Nginx controller can automatically provision SSL certificates, and now we can apply it. Perfect. We will now see that actually the operator is now running on my local system, where I port forwarded some of the important services, and also like talk to the Kubernetes API from my local system, so can easily like debug the Kotlin operator. So perfect. We are already reconciling it. Let's see which resources we already got. Perfect. This looks like a Postgres cluster. It's created already It created already the resources, now the init db, will initialize the Postgres cluster. Now we can see the Postgres is initializing. And as soon as the Postgres is initializing, then the next dependent resources will be created. Perfect. This is the Git. It has custom init containers where we try to tweak the performance of Git installations, like setting the correct amount of, if you look for a GitLab, we are, for example, setting the correct amount of sidekick workers depending on how big the GitLab instance might be, yeah? Because as bigger installations would need more worker threads, they would also need to have more memory to let all these worker threads run. So it's always a trade-off between resources and performance. And with the operator, we can also like dynamically scale up and down these resources based on external metrics, like stats from the ingress controllers. So also, I think GitLab has its own metrics endpoint to even get information about users and amount of repositories. So perfect. What we see, I think everything is already running. Let's go there, and perfect. We see actually this is how the Git operator, or the glass cube operator provisioned the Git. It's here, it's fresh to remember, and we can now register. Let's register as root. No. Yes, let's do it. Use a secretly generated password. This looks nice. So. Perfect, we registered into the Git, but do we really want to have the registration open? I'm not sure. So this is something you could normally only do via environment variables or some config. And what we can easily do, as we exposed these kind of settings in our own custom resource, we can just edit this and disable registration, because we don't want to have the registration publicly available. Looks better. Yes. I'm not 100% used with the new autocomplete instance. So we now see our operator picked up the change, started the deployment, because in the background we changed the variable of the config map, and then we watched changes of the config map, and so we triggered a restart of the deployment. This is what our operator does, but it's already running since 21 seconds. So if we go back to our Git, perfect, no register button anymore. What else can we show? Let's see if there's still some slides left. Oh, I think I finished early. Yes, I think Andy, yes. Actually, I did not prepare any end sentence, which is probably a rookie mistake. But thank you, everybody, on joining the sessions to bring you along the journey of creating Kubernetes Operator, integrating into the cloud service provider. What we do actually next, there's a demo planned at the Exascale booth right after this talk, where we show you how it would work with the GUI, so how the registration flow would work via the cloud service provider. And there's also where you can get like the suites for your GitHub stars. And yeah, thank you very much.
Very nice. As I said, finishing early, never a bad thing. Finishing late would be worse. So Git, what other things did you package again?
Yeah, sure. I think we have a backup slide. Yeah,
like 40 backup slides.
40 backup slides, yes.
Yeah.
I cut down because I was afraid of overtaking. But currently we support Git, GitLab, actually HashiCorp Vault and Keycloak, and also the tools like Matomo and Nextcloud.
So that means you're looking at these solutions, and then you figure out how do they get configured, and then you provide a CRD for it, and your operator then takes care of actually then doing the updates correctly. Yeah?
Exactly.
Yeah.
We try to go as deep into the tools because mostly the open source tools, they're not experts in delivering these open source tools to Kubernetes clusters. So we take care of that. But we are still contributing back bug fixes and also giving the open source tools the possibility to upsell their products, because in Matomo, like enterprise licenses are a huge thing, because you install the base Matomo version, and then if you want to have like session tracking or click flow analysis, you can then download the premium plugins into Matomo. And we support this as well.
Cool. Questions from the audience? We got the mic runner ready. You got a question?
Yeah, so from what I understood, your operator allows me to easily provision resources at, for instance, exascale, but it needs a Kubernetes cluster to run in. So isn't there a bootstrapping problem? How do I provision the Kubernetes cluster to run the operator in?
Basically, the operator is an open source product, so it's designed to run inside your Kubernetes cluster, and we assume you already have one. For the exascale marketplace, actually we operate Kubernetes clusters on exascale infrastructure, and you as a customer will then get a namespace inside this Kubernetes cluster secured with network policies and so on to have your dedicated installation. And you share the Kubernetes cluster, but you don't share like databases, services, and deployments. And what we will do is next, because it's like the most rich feature at the moment, are like really configurable backups and restore functionality. So a lot of customers want to have full control of the backups, so we'll provide them UI directly in exascale to have like snapshot possibilities, and then also roll back to previous version, for example, if you made some misconfiguration, which is actually not a trivial task, because obviously your database state, your object storage state always also depends on the app version state. So you can also define, we didn't show that, the app version in the custom resource, and in combination with the app version in the custom resource, we can then make the restores and backups. So yeah, another thing we are currently working on are like sandbox environments. Talking to bigger customers, we heard the problem of transparency, right? They are not allowed to just update everything. There needs to be some compliance flows, some allowance from either management or some operation team to perform some changes. But they want to know what would happen, what would be a side effect of performing this major update. And what we will do, you probably know it from like pull requests with Russell, you get like the sandbox environments for your pull requests, and we will also then provide via custom resources and a user interface preview environments for major version upgrades. So if you want to upgrade, I say Matomo or GitLab to a new major version, we can then take, because we run inside your Kubernetes cluster, can take the current snapshot with database and everything, copy everything inside your cluster, and then give you a new temporary URL with a new ingress to preview the state in a read-only or read-write behavior, and it can approve based on this preview environment, and then also delete it again. These are like the features what we have planned in the future.
Very cool. Also answers why this can't just be a Terraform provider.
Good question.
No, I think you answered it already.
Oh, okay, yeah. It's like from the inside and from the outside. There are Flux. I think there was another talk with having a Terraform controller, a Flux controller for Terraform, like there's the Flux controller for Helm. But again, this is limited to this heavy interaction with current state of the Kubernetes cluster, yes.
Any more questions from the audience? It's as simple as raising your hand. Well, I got one more. Updates. So Gitti, you showed Gitti. What happens? How is the update policy? Like, do you automatically provide a way to update things, or how do I trigger an update?
Good point. Every update from upstream we test beforehand in-house, and then provision and have two possibilities. We have a default version inside the operator. So if you update the operator, you will then get the latest and tested version of Gitti. But you can also like hard-coded the version in the custom resource. And then we are thinking about tools like writing custom matches with like Renovate. So you then can, if it's just a bug fix update, there should not be any infrastructure changes. So you can simply change the version of the custom resource, then you get the latest version of Git. But we will also have like a supported band, so a range of versions. So major upgrades would first need to be implemented into the operator, but this is our job, because I think the good thing about open source tools is that they are collaboratively developed. So they're developed in a central place, but operated in a decentral place. But the problem with operating in a decentral place is that every developer team has to take care about operations. So we want to centralize these operations with our application delivery platform, again, as we saw it with internal IDPs.
Very cool. And then to close it off, you obviously say you wanted to show how easy it is to write operators, especially in Java, encourage the Java developers. I know there's a lot of Java developers in here. So you did it. There's a great open source project where they can see how this is done in real world. They can also contribute.
Yes.
And with this, it is time for Topfenstrudel, because what I heard is there's Topfenstrudel at least served downstairs. Hopefully still something available. This is now, we're going into a 30-minute break. And then at 4 o'clock, we're here for a little surprise event and then the closing ceremony. I really hope that take the 30 minutes, a final walk through the sponsors, eat and drink whatever is left there, and then come back to hall number 4, where we close out the first KCD Austria. Thank you.